Well, hey guys, it's Michael here. Welcome back to part 9 of the 420cc Predator powered mini articulating dump truck build. In this video we're actually going to be hooking up the hydraulic to the rear dump to make that raise up and down. Going to be installing a small 12-volt hydraulic pump underneath the engine bay. And another really cool thing we're doing in here is we're actually going to be building a small adjustable limited slip for the rear diff. Alright you guys, enjoy the video. Well, my cylinder showed up. I'm happy about that. Just ordered this the other day and I'm still waiting on some parts from Surplus Center, some fittings and a hose. But this is a double acting cylinder. It's a 16-inch stroke and it is an 1.5 inch bore. Should be good for what we need back here. Double acting cylinder for down the road if I want downward force on it. But right now we're just going to be running off a 12-volt hydraulic pump my friend gave me. And this is going to work just fine just to vent the other side of the cylinder. If we ever get the other orbital valve for this thing, then we'll be able to actually run the hydraulic pump that's on here. But right now, we're really just running the hydraulic pump dedicated to steering alone. And so yeah, we'll see what we can get down the road for different parts, but let's get installing this thing. Alright, so this is about the location we want this top crossbar to be. Next I'm going to go over to the CNC and actually drop some parts for some side gussets to strengthen this, and for the cylinder hangers up top. The reason I'm starting on the top ones is they're easiest and most straightforward for me to actually cut out, and then after that we can figure out the position for them, and the bottoms are going to be a little more technical to draw up. So start off with the easiest and work our way down to the harder ones once we get this positioned. Let's go take care of that next. So I want to fit another piece right in here, get a little bit more of this metal, and this Langmuir Systems fire control has a really cool little feature on it, and that is scale and rotate. So you can actually rotate the part whatever degrees you want. I just flipped it 180 so the part's actually flipped around, and we're going to get another piece out of that. Well, hey guys, it's Michael here. If you're new to this series and maybe a new subscriber, I highly recommend you go back through and check it out from part 1. There's a lot of interesting little steps along the way and some things you may have missed out on, and you can watch this machine evolve from the ground up to this point. Alright guys, enjoy the series. Alright you guys, got this final bracket, the more complex one, mounted on here and bolted in place. I just need to tack weld it now. I want to kind of break down some solutions to problems, and anybody, if you're doing any fab work, you're going to come across problems. I've came across a lot on here and I had to come up with a lot of solutions for them. This cylinder is a 16-inch stroke. It would have been ideal to have a 15. I didn't find one available, so I found a 14, a 16. I went for the 16-inch. Basically, I have a lot of clearance issues. I have this tubing right here. I got a clearance. I could have cut it dimple out of it for the cylinder rest in. I prefer not to. I have a disc here, I have a tight section of frame, and I only got so much the bed can go up before it hits the back of the frame over here. So the way I break down problems, I work from the simplest to more complex. So I start off with the simplest. I needed to mount a cylinder somewhere across here, so I cut this tube, and this tube is actually clamped on here so you can move it up or down, adjust it at all. And then the next mount was these. These were built in a way where they could actually be slid up and down on that bar for alignment down here, and once I get that alignment right, I could tack weld those. So those were adjustable, that was adjustable. It got down here, this inner brace down here was a lot easier to mock up than this outer one, so I did that one next once I figured out right where that cylinder needed to go for the lowering down and raising all the way up, the maximum throw. And I got that one tack welded in place. Once I got it there, I was able to bolt the cylinder to that, and then I could measure off and start mocking up this outer one, which was more complex. Hope this makes sense to you guys. Just start off with a simple foundation, which adjustments, and tack welds. Tack welds are key because you can cut them off easy if you need to move anything. Start off with the simplest and work your way to the more complex parts, and by that point it'll be a lot easier to mock up because it was basically sitting there. All I had to do was just mock up the last plate because it was bolted to the inner one. Hope all that stuff makes sense. Whether you're mounting a cylinder or not, you can use that mindset to break down problems to simpler solutions. Alright you guys, let's get on to the next part of this build. Alright, I got a little 12 volt hydraulic pump with a reservoir. This is really common in small dump trucks, like if you convert a little F-250 over for a small personal dump truck for hauling gravel around your place. You're going to find a pump like this in it. My friend gave this to me. It's unknown. He said it would cut in and out. He had to replace the pump on a job because it wasn't working right, and the company bought a new one. So I'm going to clean this thing up, see if we can get it going. This is the simplest solution right now. If you guys are familiar, in my last episode, my orbital valve for the steering and my hydraulic pump were not a very good match, so I had to remove some valving off the back of my hydraulic pump. So mainly that pump just runs the hydraulics for my steering. Down the road, if I get an orbital valve that's proper for that pump, I can run my entire system, my front blade, the rear dump, all that stuff. But in the meantime, this is the simplest way to get this dump truck going, and this might get pulled off later if I can redo the system. But this is just really to get this thing moving ahead on this project and working. So let's clean this thing up and see if we can actually get it working. Alright you guys, pretty excited about this. Got a little jumper box on here, and it works. That's nice. Pretty cool. So we're on to mounting that electric hydraulic pump down under the motor here. It's starting to get a little more compact and tight in here. I got a bunch of scrap metal I salvaged from that fabrication shop. This is all stuff they bent on a box brake. Nice structural pieces, so I'm going to actually use some of this to hang this whole mount to get this pump in and out. It's going to have to actually be drilled and tapped on the side of the frame. Trying to bring everything up as high as I can for ground clearance. But having this plate down there is going to make a really nice location for me to put aluminum skid plate down underneath. If you go over anything, you'll just run it right underneath the bottom of the motor and underneath the transmission. So I'm going to get this thing mounted, and I'll bring you guys back when it's taken care of. Well, alright, my surplus order showed up, which is good. I got a hydraulic line in here, a bunch of fittings, so I can actually hook up that ram all the way up to the hydraulic pump. We're going to mount that up front. Once we get the hydraulics working for the dump here, we're going to move on to these sprockets. These are a bunch of 50 pitch sprockets in this bag, and that's going to be the final parts and pieces I needed for that external limited slip for the rear differential. Alright, let's get hooking this hydraulic system up. Alright, now I just need to finish up hooking up the hydraulic line right here. And despite how buried this thing looks like it is in here, it's really not that bad. Basically, I want it compact, tucked up out of the way. I'm going to do a skid plate underneath. And you take out these 2 bolts over here, 2 bolts over here, and the hydraulic line's even long enough where the whole thing can just lower down to the ground. You can service it and do anything you want. Keep in mind, ideally I would have ran everything off the hydraulic pump that I have on here, driven from the motor. But because I'm waiting on the different orbital valve, I can come across a 5-port, then I can hook everything up through that. And if I wanted to run a hydraulic blade up front, I can do that. But time being, this is going to be a great way to get this thing moving around. And it might be a long-term temporary. If it stays permanent, that's fine. It's nice, tucked up out of the way. Adds a little more weight over the front wheels too, which doesn't hurt for traction. All right, let's get this hydraulic line hooked up here and wire this thing up so we can start using the dump bed.
If you're enjoying the video, please consider giving it a thumbs up, leave a comment, and if you're not subscribed yet, consider subscribing. Once I get done with this project, I actually have a lot more cool builds like this planned for the near future. Oh yeah, like it says, it's salvage time. Actually, me and my brother got free range to go salvage whatever we wanted off of this bus. My friend Walter got it recently to actually just pull the Caterpillar engine out for a service truck, and he said we could help ourselves to whatever we want. I got some gauges, some electronic parts, and I actually salvaged a whole bunch of hydraulic pieces. Whenever you can salvage free hydraulic parts, it's always money in the bank for me. Pretty good stuff.
So here's part of that torque limiting coupler I got off of eBay, some of the braking material that goes on here. And I wasn't able to find the original bushing or the original sprocket for this torque coupler, so I bought this one off a surplus center. And not only does the braking material actually have to have a bushing to align it, I also have to have an alignment for the sprocket too. So I got some drawn over manual tubing here, and I'm going to take it over to the lathe and we're going to bore out a little bushing for this thing. Let's do that next. Now that we got that CV joint off of there, I can actually take this sprocket, it's I think a 24 tooth, 50 pitch, and I'm actually going to bore out the center of it so it slides over to this CV joint right up to this little step that's in here. And we're going to weld this thing on after that and do that to the other side. We should pretty much have a limited slip working after this.
So I'd like to give a little shout out to a small YouTube channel that could really use some thumbs up and some more subscribers. It's called Pine Stumps. And if you check out his channel, I'll put a link below in the description to one of his videos. He's got a lot of cool videos on this build, but he actually builds a tracked amphibious vehicle. Really neat machine, and he's actually working on a new one, so it's going to be another build series for his stuff. So please consider checking out his channel, give him a thumbs up, and consider subscribing.
So to tension the chain on here, I actually cut a bunch of these shim packs. These will just drop in right here. And when the chain stretches, I can just pull one shim pack out at a time and retighten the bolts. Pretty simple. Alright, I got the adjustable limited slip for the rear diff all hooked up here. It's a pretty neat little application. It's kind of fun thinking outside the box. I can't take 100% credit for this. My friend Dave called me up a few weeks ago and pretty much he hatched up an idea about the basics of this, and I just had to do a bunch of research and start figuring out parts, how to apply it to this. I started looking into PTO clutches. They're pretty affordable, but it was going to be too big and it's too high a torque to break them free. Could have been modified, but I just kept digging around. Another thing I looked into was electromagnetic clutch for like a mower deck to engage it. Would have been pretty slick because I just push a button on the dash and would have 100% locked the rear diff. The drawback to that in this application is if I actually went in reverse when it was locked up, it would have destroyed the clutch. That was out of the question. Started hunting around a lot on eBay and found these torque limiting couplers. This was a little over 30 bucks for this one as a new old stock. Had to build a few parts for it, as you guys know, but it's pretty simple. Some people might argue, why didn't I just buy a Subaru limited slip? Probably going to be very hard to find at some of the wrecking yards around here, especially the right gear ratio. And the wrecking yards charge probably $300 on up for something like that. Just didn't really want to spend that money. And another thing about thinking outside the box and trying something like this is if I'm happy with this, I can always apply it to the front. I don't think I'll need a limited slip up front, but there's no reason I can't add it. That's the reason I didn't weld out the rear diff solid. It's because this is a dump truck. It's going to always be hauling heavy loads in the back of it. And I don't really want to start putting extra strain and wear and tear on the CV joints and driveline just for extra traction. I would like extra traction, but it still needs a function for long term. So that's reasoning for this. All right, let's take it out and see how it does. Alright you guys, because this thing's capable of climbing up much steeper hills than I'm actually comfortable riding on it without any ROPS or a cab on here, I'm gonna try it through this woods right here. I've lost traction in this spot in the past. It's really soft, loamy soil mixed with a bunch of tree roots, and the tree roots are what I usually spin out on. It's a good way to try the limited slip coupler on the back. One thing I'm thinking is going to be going on here is the Subaru has a, I'm not sure if it's a viscous coupler or just a little diff between the front and rear axles. And at some point, maybe when I take this thing all apart to repaint it, maybe I'll weld that thing solid. But let's give it a try and see how it does. So what I'm going to do is I'm going to back off this nut on here and take off the pressure, and we'll go through that again, and you guys will see just one wheel will spin back there, just to prove to the doubters that it actually works. All right, there we go. No pressure on there. Try it again. Foot bender. All right. So in the last video, I had quite a few people comment that that's great that you make your hood fold forward and you put a winch in the way. You're never going to get your hood open unless you pull off your bumper. I don't build a machine like this and not think through things like that, guys. You gotta give me a little more credit than that. I made sure the hood opens enough to get to the gas tank on here and to do basic things like change the air filter and do basic maintenance to the motor. Anything else I need to do, 2 pins come off up front here, quick disconnect, and I can have the whole hood off in less than a minute. I think through these things, guys. Simple as that.
Well, all right, that about wraps up part number 9. Thank you guys so much for sticking out and watching it to then. I really appreciate it. Until next time, take care, guys. Bye.